topic of this lecture is triangulable matrix. In my earlier video, I had discussed what is the diagonalizable of matrix. We all of us know what is the diagonalizable of matrix. I had discussed many questions which had come in different type of competitive exam. Today, our goal is I will say triangulable matrix. Actually, diagonalizable of a matrix is extension of triangulable matrix. What is the definition? Consider a linear transformation on linear operator which is mapped from vector space to vector space. And if lambda 1, lambda 2, lambda k be the distinct eigenvalue of this transformation, then T is triangulable if minimal polynomial of this transformation is T minus lambda 1 to the power r1, T minus lambda 2 to the power r2 up to T minus lambda k to the power rk. I hope my all viewers have understood what is the difference between triangulable matrix and diagonalizable of matrix. For diagonalizable, there exists same eigenvalue, but for this same eigenvalue, there exists always different eigenvector. But here, this does not necessary. But this condition is if and only if condition, this condition. That means, if triangulable matrix, then always minimal polynomial would be such type. Also, conversely, if there exists type minimal polynomial, then obviously this transformation is triangulable matrix. Are you getting the idea? Well, actual definition is T is said to be triangulable if there is an ordered basis in which T represented by a triangular matrix. Okay, this is the actual definition of triangular matrix. As for example, this matrix, and here the characteristic polynomial would be T minus 1 times T minus 2 whole square, and here the eigenvalue is obviously 1, 2, 2. Just check on cell. For this eigenvalue, the eigenvector would be, for lambda equal to 2, I will get the eigenvector is 1, 1, 2, and for lambda equal to 1, I will get the eigenvector would be 1, 3, 2. Notice, here eigenvalue not be distinct, but here notice for lambda equal to 2, there exists only one eigenvector. So, this matrix is not be diagonalizable because here 2 eigenvalue for lambda equal to 2, but only one eigenvector exists. That matrix is not diagonalizable. For the eigenvalue lambda equal to 2, there exists one eigenvector which is actually generalized eigenvector. That means now we have to find the generalized eigenvector for the eigenvalue lambda equal to 2. T minus lambda I x equal to x1. Here obviously lambda means 2 and x1 means lambda equal to 2. I have got the eigenvector 1, 1, 2. So, matrix would be reduced as 1, 1 minus 1, 2, 0 minus 1, 2, 2 minus 2 x equal to 1, 1, 2. And notice this row is multiple of first row. So, this row would be 0. Yes, this row is 0. So, this is actually 3 unknown and 2 equation. So, obviously, x3 equal to 0. Then, 2x1 would be 1 and x1 plus x2 would be 1. That means the vector would be, solving this equation, If we construct this vector as a x2, then x2 would be half, half, 0. Therefore, this is the generalized eigenvector for lambda equal to 2. So, in my hand has 3 basis vector, which is actually the eigenvector, and for this is the generalized eigenvector x1, x2, x3. This is the basis of R3, and for this basis I will get one matrix which is similar to this Jordan canonical from 2, 1, 0, 0, 2, 0, 0, 0, 0, 1. Since here I have got this is the 2 block and this is 1 block, and this is because since here I have got for the eigenvalue lambda equal to 2 only one distinct eigenvector, so there exists one block of order 2. So this matrix is actually triangulable matrix. Have you understood the idea of triangulable matrix? Notice P inverse AP equal to this canonical form, where obviously this P means this eigenvector x1, x2 and x3, where x1 means 1, 1, 2, just put the value. x2 means this generalized eigenvector for lambda equal to 2, half, half, 0, half, half, 0, and x3 means this eigenvector corresponding to the eigenvalue lambda equal to 1, 1, 3, 2. Just put the value. Here would be 1, 3, 2. Okay? Are you getting? And this P inverse AP is similar to this matrix, which is actually triangulable matrix. That means if the eigenvalue lie in the underlying field, then always the matrix would be triangulable matrix. In particular, underlying field always would be the algebraically closed field, then any operator always would be triangulable. I hope my all viewers have understood what is the triangulable matrix. Now I will say one example which had come December 2019 Part C exam. The example is, consider A belongs to M3R and let X be the those set which contain set of all 3 cross 3 invertible matrix on the real field such that CAC inverse is triangular matrix. Notice how look like the set X. Then option 1, X is 5. Option 2, if X is 5, then A is not diagonalizable over the complex number C. Option 3, if X is 5, then A is diagonalizable over the complex number. Option 4, if X is 5, then A has no real eigenvalues. Took the option. This is very easy type and very conceptual. This concept I have discussed few minutes ago. If A is triangular matrix, that means this matrix is similar to triangular matrix A, or if the matrix A is triangulizable, that means all eigenvalues lie in the field. Now, at first we have to show is this set is empty set. At first I will say when the set X is empty, consider A be non-triangulizable matrix. Since A is non-triangulizable matrix, so obviously the root does not belongs to real field. Since here given AB 3 cross 3 matrix over the real field. For this, consider the characteristic polynomial is x times x square plus 1. Then consider the set, our given set of all C belongs to set of all GL3R such that CAC inverse is triangular matrix. This is not true. That means obviously the set is phi. Are you getting? When the set is phi, the set will be empty set when A be non-triangulable matrix. And we all of us know non-triangulable matrix means obviously the root does not belong to the field. So option 1 is a right option.
Now I will see option 2 and option 3.
Here has indicate X is empty set, where X means this set. If X is empty, that means obviously there does not exist any C in the invertible 3x3 matrix over real field such that CAC inverse is triangular matrix. Or if A is not triangular in the field R, that means there exists complex eigenvalue because triangulable means all eigenvalue belongs to in the field. Since A is not triangulable in the real number, that means obviously the eigenvalue are complex. But since here when the matrix A is 3x3 matrix over the real field, obviously degree of the characteristic polynomial would be 3. Obviously one root always belongs to real number. I have considered the root belongs to complex number, so other two root would be complex root. That means since all roots are distinct, so obviously A is diagonalizable over the complex number. That means option 2 is a wrong option. If X equal to empty set, then A is not diagonalizable over the complex number. This is wrong option. And option 3 is a right option. If X is empty set, then A is diagonalizable over the complex number. Okay. And option 4, notice here option 4 has indicated if X is empty set, then A has no real eigenvalues. This is also wrong option because since the matrix is 3x3 matrix, so for odd degree polynomial always there exists one real root. We all of us know. So option 4 also wrong option. I hope my all viewers have understood this question in a better way. This type of question actually very important for any competitive exam. But definition of triangular matrix, what is the properties of triangular matrix? When a matrix will be triangular and when the matrix will not be triangular. This concept is actually very important. If you know this concept in better way, then this type of question is very easy type question. Okay? Oh, we will see one question which had come December 2019 exam. The question is, consider AB n cross n matrix, and we say that A is diagonalizable if there exists non-singular matrix P such that P inverse AP is diagonal matrix. We all of us know this is the definition of diagonalizable matrix. AP inverse is diagonal matrix, that imply always AB diagonalizable. Then which of the following condition imply A is diagonalizable? Option 1, there exists integer k such that a to the power k equal to 1. Option 2, there exists integer k such that a to the power k is nilpotent. 3, a square is diagonalizable. Option 4, a has n linearly independent eigenvalues. Here we have to find which matrix be diagonalizable. We all of us know diagonalizable means there exist always n linearly independent eigenvectors. Matrix be diagonalizable, then number of linearly independent eigenvector is similar as number of order of this matrix. Option 4 always true option. This is actually definition of diagonalizable. Now let's say the option 2. Option 2 imply there exists integer k such that a to the power k is nilpotent. For this is actually basic. Here given a to the power k is nilpotent. That means there exists one index m belongs to natural numbers such that a to the power k to the power m equal to 0 matrix. And that imply a to the power km equal to 0 matrix. Now consider km be the index of this matrix. So that imply obviously A is nilpotent matrix. And we all of us know a nilpotent matrix be diagonalizable when the matrix is only 0 matrix. So if we consider A is non-zero nilpotent matrix, then A is not diagonalizable. Are you getting? Because nilpotent matrix is only diagonalizable when only the matrix is 0 matrix. In the question has indicate A is only n cross n arbitrary matrix. So option 2 is also wrong option. There exists integer k such that a to the power k is nilpotent. This type of matrix not always be diagonalizable. Option 3 indicate a square is diagonalizable. Then A is diagonalizable means we have to prove if a square is diagonalizable then always A be diagonalizable. For this consider A equal to 0 1 0 0. Then obviously A square would be 0 matrix and 0 null matrix always be diagonalizable. So these matrix be diagonalizable. But A is non-zero nilpotent matrix. So these matrix not be diagonalizable. That means option 3 also wrong option. A square is diagonalizable. That does not always imply the matrix A is diagonalizable. This type of question actually very conceptual question. And option 1 imply there exists integer k such that a to the power k equal to 1. We all of us know involuntary matrix. Involuntary matrix when a square equal to identity. But here a to the power k equal to 1 I. 1 means obviously this would be 1 I. That means the annihilating polynomial is x to the power k minus 1 equal to 0. Okay. And this means x minus 1, x minus j1, x minus j2 up to x minus jk minus 1 equal to 0 matrix. And this is the annihilating polynomial. We all of us know minimal polynomial always divide annihilating polynomial. And notice here all be linear factor. So minimal polynomial always would be either x minus 1, either x minus 1, x minus j1, either x minus j1 or x minus j1, x minus j2, such type. Always minimal polynomial here be as a linear factor. So when minimal polynomial be as a minimum factor, then always this type of matrix means A always would be diagonalizable. So option 1 is a right option. There exists integer k such that e to the power k equal to 1. This is obviously right option. That means option 1 and option 4 is a right option, and option 2 and option 3 is a wrong option. This is very basic and conceptual question. Are you getting? Oh well. I will stop here, and happy Durga Puja. May Ma Durga bless you with good health, wealth, happiness, prosperity and long life. Okay? Enjoy this Durga Puja. See you soon. Stay safe. Stay positive always. And don't forget to subscribe my channel for more videos. Thank you so much.